And welcome, everyone. Thank you so much for joining us. I am Teresa from Atrium Academy, and today we are really excited to partner with OpenZeppelin for a session focused on building Uniswap v4 hooks using the OpenZeppelin hooks library. And if you're new to Atrium, we partner with leading software infrastructure companies and curate transformative experiences from courses and incubators to accelerators that equip developers not just to understand new tools, but to leverage them boldly and effectively as they build stuff that matters. So, hooks, for anyone unfamiliar, are one of the most powerful new building blocks in DeFi, and OpenZeppelin's modular security first framework is already proving essential for teams shipping serious hooks logic. Um, so in today's session, Luis from OpenZeppelin will walk through core design patterns and how to avoid common pitfalls as you push the limits of what your hooks can do. So whether you're just getting started or preparing for production, you're in the right place. And I am thrilled to turn it over to Luis to talk all things OpenZeppelin and the hooks library.
Okay, so hello everyone. I'm Luis. I work for OpenZeppelin, and I'm building the Uniswap hooks library. I'm an open source developer there, and yeah. So in this presentation, I'm gonna talk about how to build Uniswap hooks, and mostly about security. What are some security concerns we must have when we are developing hooks, and everyone is welcome to open the mic. I ask for some questions while I'm talking, basically, so you are free to ask. I this presentation is a bit technical, so if at some point I'm go a little too fast or too slow, also I'm open to feedbacks at all times. So yeah, I'm gonna start the presentation on how to build the secure Uniswap for hooks, and from idea to the outed production, because into all of this at OpenZeppelin. So yeah, so like why care about security while we are developing hooks? So for those that are not very aware of like what hooks are, basically hooks are is a smart contract that adds custom logic on top of all of the swap experience. And by the swap experience, I mean both the swap or the addition or removal of liquidity in Uniswap v4. So because of that, hooks are inside all of the critical path of every swap. So they are able to touch user assets. They're able to settle and take assets from the user and from the pool manager as well, and also do a lot of different and complex arithmetics or computation inside the swap and the addition or removal of liquidity. Because of that, it can be very dangerous because the hooks are able to basically do anything within a swap, and users can be very exposed to that. So like, and also how it works is basically when you deploy a pool, when you create a liquidity pool on Uniswap before, you're able to select the hook, and then so like any smart contract that has a hook can that is deployed can be used by a liquidity pool. So when you are developing a hook, you must be aware of that, and you have to defend the hook against all of these different colors that can be calling the hook. All of the people that can be using the liquidity pool, both malicious or non malicious, and then you need to go in every case on permission flags, shared storage, fee accounting, because that's very important as well. Because hooks, they have the power to drain liquidity, freeze, and trading and all of kind of stuff inside the liquidity pool. So we need to be very careful on what we do. Also, like I'm assuming most of you know a bit about hooks, but basically we have six powerful like hook points. There's before and after swap, before and after add liquidity, before and after remove liquidity, and also before and after donate. Gas efficiency is also a very important feature, because when you do a swap, it's important to understand how much gas you're going to use, and of course the complex security of all of this that I've mentioned. So here are 5 points. We're gonna go a little in deep on all of those, which is 5 questions you must ask yourself when you are writing a hook. And these are experiences that we have seen while building hooks. Also, OpenZeppelin does auditing for hooks as well. Like I'm not involved in that, but there's also auditing. And these are some knowledge we've gained in points that it's very important to know. So the first one is the pool count. So like how many pools are gonna call this hook. As I said before, when you create a pool, you can choose a hook. So the hook can be like, if nothing is done, a hook can be used by different pools. So you must be aware of that. So if your hook, for example, takes controls of assets, or if the hook tracks some variable, you must be aware that you have different pool keys that can be accessing that hook at the same time. So for some cases, it's okay, but you must be aware of that, because in some cases you want your hook to be very specific for some specific liquidity pool. So you must be able to track that pool and not enable other ones. That's why we have before and after initialize as well. This is a way to protect your hook from from a key that you don't want to use your hook, basically. So this is the first question. You must be aware of this possibility. The second one is like pool manager calls. So the way it works, I hope like if someone who has experience with hooks already, basically the hook is called by the pool manager. So when you perform a swap, you're going to the router, but like you could go directly to the pool manager or the router, but there is a call to the pool manager, and the pool manager is the smart contract that is holding all of the tokens. So all of the tokens within Uniswap v4 are held in the pool manager contract, and this pool manager contract is the one that is calling is going to call the hooks. So basically, in this we have a lock mechanism that you are not able to like call the pool manager directly. You have to call a lock function and then have a callback. This is a way to add security and to be sure that you know what you're doing if you want to access the pool manager. So if you have a hook that for some reason wants to access the pool manager, for example, to take or to settle some tokens, some currencies, it's very important to know that, to use that in the right way. And I'm going to go through some examples here to show that. Also, the third point here is liquidity ownership, because as I've said before, the hook can be able to interact with the currencies, and is able to both take currencies from the pool manager and also change the balance deltas for the user, the caller. So there are some hooks that they own, and they're gonna effectively own liquidity and own currencies within themselves. So you must be aware of that. And it's very important to understand that in the context of how many pools are gonna be using that hook. Because if you have a hook that has ownership of currencies, for example, and this hook is used by different pools, you must you must be you need to know like which currencies are coming from which pools, and does this make sense? And like if you have users within the hook, are you tracking this variable correctly? Because if not, you can mix up the tokens from different pools inside the hook, and this can become very dangerous as well. The fourth point is swap symmetry, because in Uniswap before, like there's four times. So like when you were doing a swap, you have like two currencies. You have currency zero or in currency one, and then you can go from 0 to 1 or 1 to 0. This is a variable, of course, and also you can have both exact input and exact output. Basically you have four variations on that. And by default, only using Uniswap before they're all done basically in the same way. But you have to understand it if like, okay, so if I'm going from 0 to 1, I'm gonna have kind of uh some kind of experience, and if I'm going from 1 to 0, then I want to have a different computation on the hook. So it's very important to understand this symmetry, and if by adding the hook to the pool, you are changing how this is happening. And the fifth point is how to handle native if. As you probably are aware, in Uniswap before, there's this thing called a currency, and the idea is that a currency is both gonna handle EIC 7909 credits on the pool manager, also native if, and also EIC 20 tokens. So basically, the idea is that the currency abstraction is gonna handle everything within the pool manager. But if you're inside the hook, maybe you're gonna need to have native if within it, like in that, and then you must be aware of that, and you must use the abstraction in the right way. So you're probably gonna use currency anyway, but it's possible that you have a function that is directly called by users and not through the pool manager. And if that's the case, you need to be aware that some of the pools that are using the hook can be using native if, so you must be aware of that as well. So this is the fifth point, and this is kind of a checklist. If like when you are building a hook, if you looked into all of these points and maybe you are not sure about one of them, like I'm not sure if I'm doing the pool manager's calls right, if I'm handling the liquidity ownership right, you must redesign, and you must go back and test more. I'll always test, and have these 5 points in mind can help a lot while you're creating hooks. So now I'm gonna go to a few examples on like how this is actually done, and like some examples we have in our library, and how we can handle this point, for example.
Hey, Luis, before you move on, we have a couple questions in the chat.
Okay. Okay.
Do you want me to read it?
Okay. Yeah. Sorry. Yeah. Let me. I wasn't seeing it. Yeah. Uh, can hooks be created for swaps and liquidity pools? Yeah. Like Rafael already answered that. Yeah. Like the hooks are created for the pools, and they can change both the swap logic and the add or remove liquidity logic. They both work. Uh, Pavel asks, is it better to allow a single hook contract to be used by multiple pools, or dedicated hook contracts for a pool is better to save gas? It really depends. Depends on what your hook does. For example, if you are holding liquidity, if you're holding tokens in the hook, maybe it's a good idea to lock that hook to one single pool, because if you have multiple pools and you have ownership of different tokens, can be very difficult to track that. But if you are not doing, like, if your hook is for example uh just taking a fee, for example, it doesn't really matter which pool is calling. So you can deploy it once, and a lot of different pools can use it. So I'd say what the trickiest part is to figure out if you have some variables there. And if you have some kind of variables, it may be worth to lock that hook with a single key, in order to not have the problem of handle all of these different currencies from different pool keys. But yeah, for most of the hooks, maybe it's enough to have one hook for a lot of different pools.
What you're saying is like if the hook has like multiple accounting from different pools, really, if we're protecting different users and different amounts, that could cause
Yeah.
like yeah.
Let's say you have a hook and you have like for the users, you say, yeah, this user holds 5 if because of that pool key, and then you have multiple pool keys using it, can be tricky to know, okay, this amount is coming from this pool key or this other pool key, and this can lead to people depositing into one key, and then someone seeing the vulnerability and then uh, using another pool key to steal that money. So this is a possibility. So you need to be careful on that. Okay, there's another question, quick follow-up. How would the fees be managed for that case where you have a single pool on that hook? What do you mean you have a single pool on that hook? The fees, I don't know if I understand the question, but basically you can there's a way to override the fees, for example, and then you can take the fees of the user, for example. And if you have a single in order to have one single pool, for example, you can go to the after initialize, or actually before initialize function, and then you can check if the pool key, if the sample key has already initialized that hook, and then you can revert. So that's a simple way to avoid multiple pools in a single hook, is just going to the initialize function, the before initialize, and you are able to prevent that. Yes. Yeah. So yeah, I'll say. So here we can fees are decided during initialization of the hook. Yeah. The fees are decided during the initialization, can also be overridden on every swap. So it really depends. What? Yeah. Okay. So yeah. So like on this question, for example, one pool or many. Here I have some say on like what can go wrong is that other pools can still, if you go to the one pool only, like you want your hook to be used by only one hook. Uh, Other pools can still attach that hook by default. So you need to have some way to prevent that. So basically here is the solution. In after initializing, before should also would work. You just get the first pool key that you used and you revert in all other cases. So you are able to have a single pool key within that hook. Also, if you have multiple pool in a hook, you need to be aware of the states and the variables you are holding inside it. And the way to solve that is by having a mapping, basically. I mean, this you need to do this carefully, but is the way. So yeah, also calling pool manager, you need to call to the unlock callback. So basically, the way it works, you call the unlock function, and then the pool manager is going to call the unlock callback again, and you are going to send some arbitrary data because it's a byte to it. So you need to be able to handle this arbitrary data within your callback, and you must be sure that the unlock callback is only called by the pool manager as well. So I'm gonna show an example of that right away. So what's working. So yeah, so liquidity management and swap symmetry. So position management, it's always like if you are handling position, like when if you're calling before or after add liquidity and before or after remove liquidity, you need to know that when you are performing it, you have both the principal delta and also the fees delta. In some ways, you're gonna want to handle those differently. So you maybe you have to be aware of that. Also, it's very important to understand the concept of 6909. For those that like don't are not very familiar with it, 6909 is very likely 1155. Basically, it's the idea of these fungible tokens, multiple fungible tokens within a single contract. And the idea here, and that's all that use the flash accounting that Uniswap v4 uses, is that when you do a swap or like add liquidity, you have this credits inside the pool manager. So like all of the tokens, they're deposited into the pool manager, and then you can, for example, instead of doing a transfer from tokens, you are able to just mint or take your credits from the pool manager in the way that you have these positions, but they're actually ERC 6909 position. This is very tricky because, for example, one interesting topic is that when you are doing a hook, you can have before or after swap return delta, and then you are gonna change the output of the user. And then if you're doing that, it's possible that you want to take tokens from the pool manager to the from the pool manager to the hook address. and and it's very and one important topic is that actually the tokens, even though like when you are getting the pool manager, that you are taking tokens from the pool manager to the hook address, for example, you are able to get the actual ERC20 tokens, for example, instead of only the credits. You just have to say that use the right function. But you are even if you have the ERC20 tokens minted, like transferred to the hook account, they're actually only going to be transferred after the swap happens in because of the flash or of how flash accounting works. So let's say you have some logic where you have after swap return delta is true, so you are able to change the output for the user, and then you take some of the tokens from the pool manager to the hook, for example, as a fee. If you do that, and let's say you want the actual ERC20 tokens and not the credits, so you're able to transfer the tokens to the hook. However, if you want to, for example, send these ERC20 tokens to a different address, this is not possible to do inside the hook, because in with like in the hook itself, the token transfer is not done. The tokens transfer is only gonna be done after the swap actually happens. So you need to be aware of that, because you can have a revert on the transaction only because you are trying to access some tokens that are only going to be available after the swap happens, after the flash accounting happens, basically. So these are some important tricks that are important to understand on how flash accounting works, and how these deltas work. Yeah, and also I said about the swap symmetry, and like how sometimes you're gonna have different ways to do from 0 to 1 or 1 to 0. This is very important to it as well. Yeah. Okay, so now I'm going to some code examples on all of this. So here I have an example of pool counting, and this is the liquidity penalty hook, which is available on Uniswap on our library, but it's not released yet. It's only it is in audit, so it's gonna come in the next release. So here, when we have this hook and we want to track this variable called last added liquidity, which is when someone added liquidity to the pool, we want to track in which block that happens. Okay, this is it's a very simple concept. So like if someone as liquidity, I'm tracking which block that happened. Okay, so imagine you don't have this like here I have one mapping from the pool ID to the other mapping that is position key to block number. Imagine you don't have this mapping from pool ID to this other mapping, and if you don't have that, you could have two pools using the same hook, and then this last added liquidity could change because let's say from the perspective I just saw a question. Are there any demos or examples of hooks in use from a UI perspective? UI perspective, you mean like front end? Because hooks usually are only in the smart contract level. So you would use you would swap like in Uniswap, for example, and then the the router would go and like that pool the router would go to a pool that uses a hook, and usually you don't interact with the hook directly unless in some edge cases, but usually you only interact with the swap router, and then it goes to the hook by the pool manager. So like we're going back here. Let's say this last added liquidity variable is tracking multiple hooks, and I'm not aware of that. So basically, I deployed two pools. They're using the same hook, and then someone added liquidity to the first hook to the first pool, and then I check this last added liquidity as block one, and then someone added liquidity like the same user added liquidity to the other pool, for example. If they do that, since they added the liquidity to the other pool, the less added liquidity would be the same. So like it would be a different block, and you would have this mismanagement of the variables within different pools. So it's very important to be aware of that, in the way that since I had two options here. Either I would need to lock that hook for one single pool, or the way we chose to do was having a map and then mapping each variable for pool key. So basically, if you have multiple pools using the same hook, you are able to track that variable. Okay. Yeah, if you guys have more questions, you can say it. Yeah, so this is like the first thing, the first topic. The second one is like on pool manager calls. So we have this base custom accounting hook, which is already released in the first release of the Uniswap hooks repo. And then we have this function here, this modify liquidity function. Note that this is a custom function. It's not it's not done, it's not within the standard for base hooks, but like you can have different functions here. And the fact is there's this function, and this function want to perform a callback to the pool manager. Like, why would you do that? Like in this base custom accounting here, people are able to like have this custom accounting for hooks. So you can have different ways to represent liquidity positions. So instead of using the normal concentrated liquidity, you have your own logic for the accounting of liquidity positions, for example. And then, but you are holding the assets, the currency, the tokens inside the pool manager in the same way. So if you are using the pool manager as the contract that is storing the tokens, you maybe want some way to be able to get that tokens back. So in the hook, you can have functions that want to call the pool manager, for example, and you don't call it directly, or at least you don't call the mode like the swap or the add liquidity directly. What you do, you need to call pool manager dot unlock here. And when you do this pool manager dot unlock, you add some, you have to encode all of the data you want to send to the pool manager, so it's going encoded, and then you have to handle it some way. So in order to do that, in the pool manager, like the hook is gonna call pool manager dot unlock here and encode everything. Here we created this type, this struct callback data, which is a way to specify what the unlock callback is gonna use. And then here we have to implement this unlock callback function, and we can decode it here. It's very, very important to see that we have this modifier here, only pool manager. And why is that? This function, this is a public function, external, so anyone could actually call it if you don't have that modifier. So you need to be sure that that only the pool manager is gonna call, and the pool manager is gonna call this function in a callback for this. So basically the idea here is that you do unlock, and then the pool manager calls this function here, and then you have the logic within it. The next example is liquidity ownership. So here we have base async swap, and what is the idea of base async swap is quite simple actually. So when you perform a swap, let's say you want to do an order book, for example, you actually want to take the tokens from the user and not perform the swap itself, and then you want to, for example, hold these tokens in the hook and to do whatever you want later, but like an order book. So how you do that is you use this specify.take. This take function here, we have an utility library for currencies, which, because when you take, you are taking from the pool manager, you can actually take or mint. There's the two possibilities depending on what you're doing. And in order to abstract that in a better way, we created this utility called currency settler, which is the one that enables this kind of use. So here, in the case of like param amount specified lesser than zero, like we do here to see the specified amount, and then we can take the tokens from the pool manager. So here you can see that it takes from the pool manager, and address this is the address of the hook. So it holds the assets and takes the assets from the hook, from the pool manager to the hook. And here it's gonna this true here means that you when you this true here means that you are actually minting the tokens to the credits to the transfer. Yeah, take meaning transfer or what? Yeah. So basically, when you J and BAZ, how he asked, uh, this take here can mean or both transfer or mean to the ERC 7909 transfers to tokens to the hook. So the idea here is that if it's true, you are actually minting. So yeah, true. Yeah, true means you are minting the tokens from the pool manager to you are minting instead of transferring the tokens from the pool manager to the hook. If it's false, it's the contrary, so you are transferring. It's important to know that in either case, this is not where the transfer is happening. Actually, the transfer only happens after the swap because you have the flash accounting stuff. So even if you take here and you put false in order to have the ERC20 token, you are not able to transfer the ERC20 token right away. You need to do it. You can do it within the hook itself. You need to do it after the hook call. So yeah, this is very important to understand, and how to handle this liquidity inside the hook. Yeah, and swap symmetry here is basically this is from the anti-sandwich hook that is also not released yet. So basically here it's possible to do different swaps depending on if you are 0 to 1 or 1 to 0. So it's very important to know how to understand how the state of the pool is gonna be after the swap happens, because you are actually doing it in a non-symmetrical way. So you need to be aware when you are doing this, if you mean what you're doing. And last, as the example, we have the handling native if. Most of the handling native if is gonna happen when you have functions that are called directly by the user, and not sorry, they're gonna be called directly from the user and not the pool manager. So if you are doing that, you need to be aware of message value, for example, but you're gonna treat this as a currency, as an ERC20 token, the same way. Okay. So this is one topic that you need to be aware, mainly when you are handling native if, mainly when you are doing these functions that are exposed directly to the users and not to the pool manager. And yeah, and also important that uh, the currency 0 and the currency 1 inside a pool, they are ordered by number. You see the address of the tokens as a number, and if like the native currency is 0, so always if is gonna be the currency 0. So is a way. So here is the way that we can check if you are treating native a pool with native token. Basically, you go to the currency 0 because it needs to be the currency 0, and then you check if the address is the 0 address, and then you have if, basically. Oh. Okay, yeah, and now that I already mentioned these designs and like how to think on everything, I'm gonna talk about what we are bringing at OZ, and what which modules you have, and how you are able to inherit from them and use them in the hooks you're building. So basically, we have 5 different modules here, and we have abstract and some ready hooks where people can use it. So the first one is the base module, which have the more abstract patterns, which is like the most simple standards for when building hooks in order to create. So we have the base hook, which is the real base. We have also the custom accounting, custom curves, like base stuff where anyone can inherit from. This this module solves some delta settlements, some hooks permissions, because you need to have a function to get the permissions of that hook. So basically, the base ones are more for this standard on the beginning. There's the module on fees, which is different ways to handle fees. Basically, you can override fees. You can have dynamic after fees, which is like dynamic fees after the swap. You can have dynamic fees So we provide these standards on how to deal with swap fees in different ways inside our library. And basically the idea here is to help with like race condition and like poke helpers as well. So the general one is the one that we are developing now, like both the base module and the fee module, they are already released in milestone in the first release we made. The general one are some kind of ready defensive hooks that are already that they're in audit right now, but when they're released, they're gonna be some example hooks where people can go there and see how they work for, like, for example, for anti-sandwich, like preventing MEV attacks on hooks, also preventing just-in-time attacks, some limit orders. So basically some use cases where people can leverage, and some protection hooks as well that they can use. Okay, Todd asks, can you say more what anti-JIT works? Yeah. Okay, JIT is just-in-time liquidity. Basically, just-in-time is, let's say you are performing a swap, and then someone with a lot of liquidity can add a lot of liquidity before the transaction happens and remove it after the swap happens. This is usually when the swap is really big and the fees are going to be high. So it makes sense for someone to add a bunch of liquidity, and then they're going to have 90% of the liquidity in that range, and then they're going to be able to take most of the fees of that particular swap. So they're able to get a bunch of the fees, and they don't incur in some of the risks that liquidity providers have. So when you are a liquidity provider, you have risks, for example, such as impermanent loss. You have loss versus rebalancing risk, like some is that you can lose money on. And if you do some just-in-time liquidity, you don't have that risks. You only need to add a bunch of liquidity and remove it fast to make money. For the point of view of users like swappers, it's actually good because if you increase liquidity, you can have better pricing. But if you are looking to liquidity providers, and mostly longer term liquidity providers, it's complicated because if you have long term liquidity providers, they're going to incur in some of the risks, and it's bad for them if like someone does front running on them basically. So we do this, and we have this hook called liquidity penalty, which is basically if you provide liquidity and then you remove with in the same block, for example, we take a tax on the fees you were gonna receive, and we donate back to the longer term users, the longer term liquidity providers. So the idea here is that is a way to incentivize more longer term liquidity provider and do some penalty on these kind of attacks. And we have these interfaces. For now, the only interfaces we have is the iHook events. And why is that important? Was actually a request from the Uniswap Foundation, because it's very important to be able to track when fees are taken, revenue for hook developers. So if you are a hook developer, you should consider using this interface, because it's going to be a much simpler for people such as the Uniswap Foundation itself to be able to track revenue and fees generated by hooks, and in a very standardized way. So this is the standard to be able to, so people are able to track all of these types. Also, we have the utility here, and these are some helpers basically. The currency settler is the one that we have right now, basically to do some helpers with currencies, which is a kind of complicated thing, because you can have both, for example, take and mint. You can use it in different ways. So we try to abstract that in these utilities. So yeah, just going a little bit. The base module here, we have four. We have the base hook. The base hook is the, like, if you are doing any hook, like you don't have some specific pattern, you should use the base hook, which basically explodes all of the functions you need to create, and also and how to handle the permissions you need, basically. So this is the base one. And the custom accounting is, let's say you want to do some you people are adding liquidity directly to a hook and not to a pool, for example, and you want to track that in a different way. So instead of having the accounting that a router does, you want to do that through a hook itself. For example, you want people to add liquidity, and then you want to create, and you want to manage the positions itself, you maybe want to do via a custom accounting. A base custom curve is a very interesting one, because we have a constant product AMM within Uniswap before, using concentrated liquidity, but sometimes it would be interesting to have different swap maps or swap logics. You have stable swap, you have custom sum, market makers, and then you have some price curves in a different way. In the past, this was not available on Uniswap, but now you can inherit from the custom curve, from the base custom curve, and add your own curve to it, and then you have a hook that people use through the Uniswap protocol, but have a totally different math within. Also, we have the base async swap. Base async swap, it was called base no op in the past. Actually, when I did the Atrium Academy, I myself, I did the Uniswap Hook Incubator. The name was base no op, which is basically a hook that it disables the swap itself, so it takes all of the input from the user, and then you perform nothing. Now we are calling it base async swap, which is basically the same thing. We stop the swap, and in order to other thing happen later. This is usually, for example, for order books or other kind of ideas that have this. uh Fees, like there's some flavors on fees. There's some things you can do. So like when you do a swap, of course you pay fees for the liquidity providers. You could also pay protocol fees, but the fee switch is off right now from Uniswap. This is decided by the Uniswap DAO. It's currently off, but you have swap fees. But as a hook developer, you are able to override this. So you can see that for there's the dynamic fees that are used in Uniswap before, and you are in this dynamic fees. We provide the standards on how to perform this. So basically, if you have a dynamic fee which can be triggered every block or every swap, you're able to just call this like poke function in order to like change fees and this kind of have this dynamic fee. This can be very interesting if you have, for example, an MEV tax. That's a possibility. You have other different aspects, or other different attacks, or ways that people are performing that you want to change it. So for example, depending on the volatility, you maybe want to have less fee or more fees, for example, and you are able to do this on the base dynamic fee. So you can inherit from this fee, so from this hook, and add your custom dynamic logic. Also, there's the base of override fee, which is like this one is before each swap. So like if you have basically a volatility based or a MEV based, or like some logic like that, you are able to override it. And there's this base dynamic after fee, which is the trickiest one, to be honest. This one here is a fee that is not a liquidity provider fee. Actually, it's a fee that kind of the hook is like after the swap happens, the hook is like taking some of the output from the user for some purpose. For example, this can be, let's say you want to add a fee to a simple fee to your hook just for using your hook. You should be using the base dynamic after fee, and then you should emit the iHook event fee for that in order to be able to do it. And then in the standard we created, uh, one idea is that you can get the fee from the user, and then you can, for example, donate it back to the pool, or you can just retrieve as a fee to the hook developer itself. This is one method basically. Yeah. Okay. So in general, there's 3 hooks right now. We're developing now. These hooks, they're not released yet. They're on, you guys can see it on master right now, but they're not on the release. They're passing through some audits. They're kind of tricky. So I'm developing them. So basically there's 3, and the idea here is to showcase how people can interact with the base ones and create very specific use cases and develop on top of them. So the first one is the anti-sandwich hook. So basically we use this article on an idea of a of anti-sandwich AMM, which basically enforce a price cap, like in each block, if you do not increase the price of for like buying, and so you keep the price fixed within a single block if you're buying, but not if you're selling. So this is a case where you treat differently if you go from 0 to 1 or 1 to 0. And the idea here is that sandwich attacks, so MEV, people can they do front running, and if you add this hook to the pool, user like attackers are not going to make any profit by front running people. So this is a hook that protects them from this kind of attacks. In the same way, there's the liquidity penalty hook, which is a hook to do some kind of taxing if someone is performing a just-in-time attack. So this is an attack to liquidity providers, and this is also can be a way so that people that are creating a pool, for example, they design a way to reward longer term liquidity providers. So you have an incentive to be a longer term liquidity provider, because if you remove your liquidity too early, you're gonna the fees you are gonna receive, they're gonna be taxed. Basically, that's the idea of the liquidity penalty, and this can be used by a lot of hooks as well. And also there is the limit order hook. The limit order hook is a bit different. Is how to place an order in the the curve. The way to add it to the curve is that you can add liquidity to the pool at any tick, even if the tick you want to add liquidity is not currently in range. So the idea here is that you add liquidity to a tick outside of range. So when like if the price moves and the price reaches your tick, then uh, you're going to have your position changed, like because you have you were in a single token when you do an addition of liquidity outside of range, you add to in a single token. So when you uh, you cross that tick, you go from one currency to the other. So you actually kind of perform the swap within the curve, but in a limit, like in the way that the limit order works. So this is an example on how we can leverage the AMM and the like how we leverage how Uniswap works in a way that you have a totally different way to do swaps using limit orders, for example, and they're actually using the addition of liquidity as a way to do a swap, for example. Yeah, and this we have these interfaces for the standard events. As I said, this is important the mostly so people can track. And by people, I mean anyone on chain, and in particular Uniswap Foundation. They want to be able to track and showcase how hooks are doing. Also, hook developers may want to show how their hooks are doing in terms of revenue, in terms of fees generated as well. So you should look at these events and emit these events in order to in order to be able to track them in a better way. So these are the four types of events. When you do a swap, when you have a hook fee, you also like if you have a particular fee that you are retrieving from the user, adding to the LP fee, you should emit this event. Also, when you do some liquidity modification, addition or removing liquidity, and the hook bonus is when you donate. So when you do some kind of donation within a hook, you should emit this event. This is basically for being able to track, and people can track it better in Dune, for example, do a Dune dashboard, for example. Yeah, so in terms of developing the workflow, we're almost on time here. So I'm just gonna go like very simply on how people should use it. Today, you should use Foundry. This is how we are developing it. Soon we're gonna launch also an npm version of it, so you can also install. You're also going to be able to install it to hard hat, for example. But for now, use Forge Foundry to install it. So you're able to just like you install OpenZeppelin contracts and Uniswap, you install OpenZeppelin slash Uniswap hooks, and you're going to inherit from the contracts and test them. This is very important. Yeah, so just some things on like roadmap. We have a lot of guidelines and like how we build on OpenZeppelin. Like security is the number one topic for us. So in this presentation, I try to talk about some of the points we need to take into consideration when we are developing any smart contracts and hooks. In particular, all of the releases are audited by all of the release are audited by the auditing team on OpenZeppelin. So, and we have the milestone one audited for the base hooks, and now we have some more coming to the next release. Probably by the end of June. That one is expected end of June, beginning of July. What is being built is all open source. You can go there, you can maybe propose PRs. We're gonna look on them, and yeah, that's what we're building. Thank you very much. Thank you all for being here. I didn't go much into like creating. I was like expecting to have time to build the hooks, to build a hook with you guys, but I think I took a while. So yeah, go there, install our library, try it out, and if you have any feedback or any comments, we're always open.
Amazing. Thank you. That's just a good excuse for y'all to come back and do some more building with us. So I appreciate you taking the time and walking us through the hook library and how OpenZeppelin thinks about hook building and is making things a little bit easier. Um, and for folks interested in learning more about hooks, Atrium's next Uniswap hook incubator starts in July. So consider joining us for that. And then you really can start to add OpenZeppelin hook library modules into what you're building. So thank you, Luis. Thank you, folks, joining, and we'll end it there.
Thank you very much. Thank you, everyone.
Thank you. Great event.